comprehensive explanation of writing and managing integration tests in Go. This mind map provides a structured approach to writing and managing integration tests in Go. Here's a detailed explanation of each section. 1. Define integration test files. Integration test files are organized for clarity and to differentiate them from unit tests. Use test.go suffix. Integration tests, like unit tests, must have file names ending with test.go. Place integration tests in a dedicated folder, such as tests/integration, to keep them organized and maintain a clear separation from unit tests. Naming conventions. Use clear file naming patterns like integration test.go to identify them easily. Why it matters. Organizing tests simplifies maintenance and makes it easier to run specific types of tests. Use testing.T. The testing.T type is the core tool for managing test cases and reporting failures in Go. It is used to validate interactions between systems. Manage test cases. Use testing.T to check for errors and validate test results. Example use case. Integration testing often involves external systems like databases or APIs. For example, connect to a database. Test whether the application can successfully connect to a database. Validate queries and results. Ensure queries execute as expected and return correct results. Why it matters. Testing provides a simple way to handle test logic and report errors for integration tests. 3. Set up and tear down with TestMain. Integration tests often require a global setup, e.g., starting a database, initializing services, and cleanup after tests complete. TestMain enables this functionality. Purpose. Provides a global mechanism to set up and tear down resources before and after running tests. Steps. 1. Set up environment. Prepare resources such as databases or external services. 2. m.run. Execute all the test functions in the package. 3. Tear down environment. Clean up resources like database connections, files, or containers after tests finish. Why it matters. TestMain ensures integration tests are executed in a consistent environment, reducing errors caused by resource dependencies. 4. Use external tools. Integration tests often involve dependencies like databases, APIs, or services. External tools help manage these dependencies. Docker. Use Docker containers to spin up services, e.g. databases, APIs, in isolated environments for testing. Build tags. Use Go's build tags to selectively run integration tests. Add a build tag like /build integration to the test file. Run the tests using GoTest tags integration. Why it matters. External tools like Docker and build tags help automate the setup of testing environments and allow selective execution of integration tests. 5. Best practices. Follow best practices to ensure reliable, efficient, and maintainable integration tests. 1. Isolate test environment. Use separate databases or containers to avoid impacting production systems. 2. Use mocks and fakes. Replace external systems, e.g. APIs or unavailable services, with mocks to simulate their behavior. 3. Keep tests fast and focused. Ensure tests focus on specific integrations and complete quickly. 4. Clean up resources. Always tear down resources, e.g. close connections, stop containers, to avoid resource leaks. 5. Parallelize tests. Use t.parallel to run tests concurrently and reduce overall execution time. Why it matters. Best practices ensure integration tests are efficient, reliable, and do not interfere with other systems. Summary. Integration testing in Go focuses on validating interactions between systems, such as databases, APIs, or services. By organizing test files, leveraging testing.T for validation, using TestMain for setup and teardown, and integrating tools like Docker and build tags, you can create robust and maintainable integration tests. Following best practices ensures tests remain efficient, isolated, and easy to maintain.